Geotechnical Engineering Part 8 Soil Mechanics. Good night, everyone. Let's review an interesting concept in soil behavior in terms of rigid soil and flexible one. So just consider like in mechanics, like if we have a rigid body, like a rigid foundation over like a spring 1, a spring 2, and a spring 3. The 1 and 3 are the strong springs, and the middle one is a bit weaker. So if we have a rigid foundation on this configuration and you apply a force of F, rigid body, in rigid body delta remains the same and F is proportional to stiffness. So in rigid body we do know that the stiffness draws forces, stiffness draws force in a, so it just says the foundation displacement is delta at each side, so it uniformly moves down. Delta remains the same in rigid bodies, and but the force, we can easily know the bigger chunk of force, like F3 is equal to F1 and it's higher than F2. The weaker one handle a smaller portion of energy and the too strong holds the bigger chunk or stand the bigger chunk of force or energy. In the other side, in flexible bodies, if you apply a force over a flexible foundation over the same springs, it just behaves like this. The weaker one moves down, more down than the side. So delta 1, delta 3, delta 2. Delta 2 is the biggest one. So again, one can say in flexible body, force remains the same, but delta is proportion to inverse stiffness. So because force should remains the same, if K goes down, delta is going higher. So this is weaker. So K is smaller. That's why delta 2 is bigger than the sides. So if we want to apply this concept to a foundation, so we can say softer member has higher displacement in flexible foundation or bodies. So let's apply the same concept to a rigid soil. Let's consider we have a rigid body and we have it like we want to investigate sand and clay when they are in a rigid mood. So if we just consider the contact pressure and settlement, settlement just says a consolidation settlement, that's a delta H over H, and that's a delta. That's a settlement. That's the delta of soil. Mhm. And contact pressure is nothing but sigma is force over the area. If you remember, we already told that the in rigid body delta remains the same. So if we have like a rigid body, it doesn't matter in which soil you are, settlement remains the same in both of them. So settlement in rigid body remains the same. You can easily see that the delta at the beginning, at the center, and at the end so remains the same amount of delta for both foundation, and at the center, at the middle, and at the end. At the center, at the beginning, and at the end for both. But the contact pressure is like this is for sand, and we do know in sand soil C is equal to 0. So as you apply a force over it, the sides are weak, and sand can easily run from the side. It runs from the side. So That's why F is proportional to it, because this is to a stiffness. So this is the weaker part, so less energy, and at the center, bigger chunk of energy. That's the distribution of stress distribution or contact pressure for a sand in rigid condition. But for clay, you can easily see soil want to run from the sides, but because in clay soil we do have cohesion, so these are the strong part. It doesn't let the soil moves from the side. That's why it just move, the contact pressure moves up to a higher amount, and then suddenly the soil should run from somewhere. It just move or run away from the center, so it just decreases. Contact pressure decreases from the side to the center. On the other hand, if we want to review the effect of or behavior of flexible foundation, like in flexible sand and flexible clay, you can easily see in, if you remember, in flexible body, force remain the same, sigma is F over area. So if force remains the same, let's say contact pressure in both of them remains the same, but the delta is proportional to inverse of. So in sand, C is equal to 0. These are the weak part. So inverse delta is proportional to inverse of a stiffness. So this is the weaker part, goes down, all the way down, and the strong part at the center experience the less delta. So the softer part or the less stiffness moves higher. So that's the shape of settlement of a sand in a flexible condition. Likewise for clay, because the cohesion is not equal to 0, the sides are strong, so the weaker part experience the highest delta, and the sides are strong. The sides, it doesn't let the soil run from the side. If we want to wrap up the this concept in sand, so we can say sand is dissect to rigid and flexible. It can be either of them. In contact pressure for a rigid one, you can easily see the sides are weak, so soil can run, but the center experience the higher pressure. In terms of settlement, that's unique for rigid body. And for flexible one, so the pressure remains the same, and the settlement is inverse to stiffness. So the sides are weak, so they goes more down. And like in clay, we can have a flexible clay and we can have a rigid clay. So in the rigid one, the contact pressure is like what you can see here. Sides are stronger and the soil ran from the center, so contact pressure and settlement in rigid is remains the same in every part. And in flexible clay, you can see the contact pressure remains the same and the sides are strong, so they cannot run from here, and the weaker is a, a weaker, so it just moves more down. Thank you. We'll solve problem in next videos.